MOAs before Mars. Yeah, it's incredible visual, right? It's a window into developmental biology, which is amazing. So you can actually see and understand the progress, right? But also, to your point, it's also very physical. And so not just the developing embryo, because we see a lot of that stuff in cells and in culture, but to actually have like the culmination of like the cell engineering team, the animal operations team, and the hardware team coming together to where this is not just the incredible biology that you're getting a window into, but you're getting it through the lens of this like physical device that is supporting it, right? That was human made instead of just nature made is really, really cool, right? And I think that not only does it add this like layer to the amazing sides of nature and being able to have a window into that nature, right? But also it shows that we can replicate nature and in some ways even improve upon nature, which is really interesting. So for us, like we didn't want to just like reimagine the egg. We wanted to completely re-engineer it. And one of the things that I think will be probably lost on people, and you know, there's only so much you can put like in a press release, is not only did we have to develop the structure and do material sciences on that membrane that's in there, but another thing that we had to do is that if you look at an egg, right, just a normal nature egg, which is amazing, and it's self-contained. It breathes, and so you have to have that porous nature of it. But in addition to that, it's self-contained, and there's actually like pressure, not just atmospheric pressure, but there's pressure, and there's the right size from a developmental biology perspective that the developing embryo needs to adhere to, right, in the right curvature and shape. Well, think about this. If we're going to change the shape, right, and so if you notice our artificial egg system, we have that very large windowing at the top so that we can look at it from a developmental biology perspective. We could supplement it. We can edit it if we need to. Having that access is amazing, but it changes the shape that's been so perfectly designed by nature. And it's not, if you took an embryo and just put it, on like a flat, little bowl or something, it would develop a little bit, and people have done that before, but it won't develop the whole way. We actually had to re-engineer and think about the pitch of the internal egg, because if you're flattening the top, you have to overcompensate in that curve so that you get the same not just structural integrity, but you get the same pressure. And so that is like really hard. And most people they'll just see like, oh, it kind of looks like an egg, but it's like, we actually had to look at the grading internally to ensure that there's the overcompensation for the flat part that we made at the top. Yes, we really wanted two core reasons. Number one is our MOA project, right? And so, there's 9 species of MOA. We're working on the South Island giant MOA, which is the largest MOA that ever existed. And just the egg is about 8 times larger than an emu egg. So from a gestational perspective, we either have to engineer much larger surrogates or be able to birth through an existing size surrogate, a South Island giant MOA egg, and then transfer it to a larger system that you can also then supplement, right? And so for us, I think that engineering challenge is a more thoughtful one than just trying to engineer giant surrogates. Like that seems like it's something that we could do, but it's not something that I think is probably the most efficient use of our time. And then also the same system can then be applied to conservation where you have a limited surrogate. So you could leverage that primordial germ editing model in genetically modified chickens, right, to make those chimeras so that you could engineer, and use like a readily available like chicken type surrogate, and then transfer those for size variants into the right size for artificial eggs. You don't have to go the size of a giant MOA, right? You could get them to the right size for that specific species where you have a limited number of surrogates. So the ability to create a larger egg construct for the birth of the South Island giant moa, as well as have applications for scalability in different sizes for conservation, was something that, made a lot of sense. When you have a threatened species, you typically have less of them, right? Or genetic bottleneck. So this allows us to do two things. One, leverage an existing, more available surrogate model like a chicken, right? And so you could have like your sire, the same process we're going through the dodo, you could have a sire dam chicken model where you've got these genetically modified birds, chickens, that take the, in this case, endangered primordial germ cells from a parrot or a kiwi or whatever, right? And then you could put that into your chicken model. Your chicken could give you your eggs, but knowing that it's not the right size, you're going to have a developmental biology issue, or at least a potential developmental biology issue from that. So then you could transfer those into artificial eggs, right? And then you could use your chicken model or another readily available model to birth a lot of different eggs that then you transfer into artificial eggs that will then grow at the right size and scale from a developmental biology perspective to actually birth them, right? And so that then you don't need to leverage the critically endangered species for a surrogate, but you're not limited based on size and shape of the chicken model, because it could just be transplanted in and supplemented into that of the artificial egg construct. Dinosaurs and what's next, and then the timeline are the three questions we get consistently. There's been a rise in requests for Megalodon, which is a little disturbing. And so we don't have a set timing. We have not made any announcements in the genome work or the PGC work. Obviously, we've done that on the dodo side last year, and that infrastructure that we built around our avian facility, our avian genomics lab, and the work that was done to dodo will accelerate that work for our MOA project. I'm hopeful by the end of this year we'll have some announcements over the progress of the genomes, because there's not even genomes for them, right? Like, the benefit of the dodo project is while there's one genome, Beth worked on it for like 15 years, right? So that's, we're kind of cheating because we have Beth Shapiro who worked on it so much of her life, right? And that doesn't exist for the 9 species of MOA, specifically the South Island giant MOA, but we're hoping to change that. MOAs before Mars.